Hello friends, hope you are doing well. Myself Mohammad Furkhan and today we are going to cover atom and molecules. This is the third chapter of 9th standard science book entitled as Atoms and Molecules, and this chapter includes following topics like laws of chemical combination, Dalton's atomic theory, what do we mean by atom and molecule, how to write chemical formulae, and what is molecular mass and what is a mole. So we are going to cover half of the portion in this video and the remaining portion will be covered in upcoming video. So it was Maharshi Kanad who postulated that when you divide a substance or a matter into smaller particle and keep dividing it, a time will come when you cannot divide the smallest possible particle, and that smallest particle which cannot be divided further is called as Paramanu. So what is Paramanu? Paramanu is the smallest particle of matter which cannot be divided further. Katayama further elaborated this doctrine and said that any Paramanus they are combined in a fixed proportion in any given matter. So what is Katayama said? He said that the Paramanus or the matter are combined in various forms in a fixed proportion. So as we know that when we say water molecule, the hydrogen and oxygen when combined with each other in the ratio of 2 of hydrogen atoms and 1 of oxygen, they form H2O, and that is the fixed ratio of both of these. So this was the concept which was proposed by Katayama. Then Democritus, a Greek philosopher, called these Parmanu or indivisible particles as atoms. So we have seen that what is Parmanu, how this Parmanu or the atoms are combined with each other, and what is an atom. So all this till now was the philosophical world, and now the scientific basis for the proof are given. So it was Antoine Lavoisier who was also considered as the founder of chemical sciences. He has established two important laws of chemical combination. These laws were as follows: laws of conservation of mass and law of constant proportion. So what is the law of conservation of mass states? Law of conservation of mass states that mass can neither be created or nor be destroyed in a given chemical reaction. So when you try to perform any chemical reaction, mass can neither be created nor be destroyed. Only the forms can change when molecules or atoms get interacted with each other. Because of their attraction and repulsion, they will form a new substance, but mass remains same. And the second postulate states that law of constant proportion. So in a chemical substance, the elements are always present in a definite proportion by mass. For example, when you see water, so what is water? Water is H2O. This is water. And when you take H2O2, it is hydrogen peroxide. This is water. This is hydrogen peroxide. So both are different from each other in various forms. Their chemical properties are different, their molecular mass are different, and their behaviors are also different. So in any given substance have fixed proportion of the atoms present in it. Okay, so let us move to the next topic, Dalton's atomic theory. So all the matters, whether an element, a compound, or a mixture, they are made up of small particles that we have seen, and this was postulated by Kanad Maharshi and also by Democritus. Okay, so now let us see what Dalton's has postulated about the atoms. So he has postulated 7 different criterias or characteristics in his atomic theory, which includes or which states that matter is made up of very tiny particle, as we have seen earlier also, and he called these particles as atoms, as stated earlier by Democritus. Then he said that the atoms are indivisible particle. This also we have seen. Then atoms cannot be created or destroyed in a chemical reaction, as given by Katayama. He has said the same thing again. So next postulate or next element, he said that in atoms of a given element are identical in mass and chemical properties. So what does he mean here? That when a given substance is there and when a given substance of single type of element is given there, so the mass of each atom of a given element or pure element remains same and their chemical properties remain same. For example, when you consider O2, O2 means oxygen. Oxygen is an a compound, and oxygen's molecular weight remains same throughout the substance. Or when you consider element gold, okay, so all the particles present in gold are of same type, and the molecular mass and chemical properties of gold, each atom of gold are same. So what he said in his next theory, atoms of different elements have different masses and chemical properties. Yes, that is correct. For example, when you see hydrogen and oxygen, so these are two different elements. Hydrogen supports for burning, sorry, hydrogen is combustible and oxygen is supporting for the combustion. So both of them are different, their masses are different. Hydrogen's mass is 1 while oxygen is different. So the what he mean to say is that two different elements have different masses and chemical properties. Next postulate or next element of his theory states that atoms combine in the ratio of small whole numbers to form a compound. Like hydrogen, when combined in two ratios with oxygen, it will form H2O. This is water. When oxygen is combined in two molecules with hydrogen's two molecule, it will form hydrogen peroxide. When hyd four hydrogens are combined with carbon, they will form CH4, which is methane. So as you see here, this is 4. Earlier you have seen that hydrogen is combining in two form, oxygen may combine with one or two mole atoms. So these are the whole numbers. We have not seen that H1.5 plus O.5, right? So this is not the whole number, and this is what he wants to say, that when any atom combines with other atoms, they will form in a whole number. So the last point of his theory states that relative number and kind of atoms are constant in a given compound. So for example, whatever the compound that we take, like if we want to see NaOH, so whenever you see NaOH molecule, all the molecules in NaOH are having one sodium atom in it, one oxygen atom in it, and one hydrogen atom in it. So this is the fixed proportion of 1:1:1. So this ratio remains fixed throughout the molecules of NaOH or sodium hydroxide. Okay, this is what he wants to say in this postulate. So we have seen that all matter is made up of tiny particles that are called as atom. Atoms are indivisible particles. Atoms cannot be created nor be destroyed in a chemical reaction. In an element, all the atoms are identical and their chemical properties are identical. Atoms of different element have different masses. Then when you combine different atoms with each other, they form a ratio which is in a whole number, and the relative number and kind of atom in a compound are always fixed. So this is what Dalton has postulated. So what is an atom? Atom are very small. They are smaller than anything that we can imagine or compare with, because their size may come in 1 nanometer. The radius of an atom is 1 nanometer. 1 nanometer is 1 divided by 10 raised to 9 meter, or we can say that 0.000000001. So this is nanometer. So the size of atom is so small that we cannot generally imagine it. Okay, so more than millions of atoms, when stacked with each other, they will form a thin layer of paper. So when you see our notebooks paper, they are having millions of atoms combined with each other in that. Okay, so what is the size of atom? Atom is in the size of nanometers. So you can see here an illustration. Watermelon is having the radius in 10 raised to minus 1. 10 raised to minus 1 means 10 centimeter. Then ant is 1 centimeter. Giant grain of sand is 10 raised to minus 4. Then hemoglobin molecule 10 raised to minus 8. Water molecule 10 raised to minus 9. And even further lower, hydrogen atom 10 raised to minus 10. This is the radius of hydrogen atom. So 0 and then 9 times 0 and then 1. So this is the radius of hydrogen atom. Okay, so previously atoms were given certain symbols and they are represented based on their symbols. So it was Dalton who was first scientifically used the symbols, and he has specifically given some symbols to particular atoms. Like hydrogen atom is given with one circle and dot in the center. Carbon is complete filled circle. Oxygen is completely empty circle. Iron is circle with I in the center. So these are the some symbols here they have postulated in previous methods. So it was Berzelius who suggested that symbols of atom, symbols of element be made from one or two letters of the name of the element. So based on this, new postulate theory were evolved. So earlier, the names of the element were based upon the city in which they have first observed or obtained. For example, copper was taken from Cyprus because it was first found in Cyprus. And another possible way to name the atom is gold. Gold was given based upon its specific color because gold has got its name from English word yellow. Okay, so in the present day, it is IUPAC. It is IUPAC means International Union of Pure and Applied Chemistry, who is in charge of giving symbols to the new discovered atoms. So what this method states, when you want to write the symbol of any element or any atom, you have to take the first capital letter of the name and later on followed by letter which is smaller in case, or lowercase letter. For example, when you want to write hydrogen, its symbol is H only, so you need not to write any other letter after it. But when you want to write aluminium, aluminium is having two letters A and L. So this L should always be smaller. Means you should not write A and capital L because it is a wrong practice. You have to write A capital and L small. This is the way you have to write. Another example is of cobalt. In cobalt it is C and O. So cobalt symbol is C and small o. You should not write capital C and capital O because it is wrong. You have to write capital C and small o. This is in this way you can write, or you can represent the atoms based upon their symbols. So the new method for symbol of atom has given so many symbols, and now we are following the same method. For example, for aluminum Al, for copper Cu, for nitrogen N, for zinc Zn. There are so many symbols already present and around 114 known elements were there. So the symbol of iron is Fe, which is based upon the Latin name for ferrum. Sodium is given Na based upon natrium. Potassium is given as K because of kalium. So certain names which were previously assigned to a particular atom, they were carried forward, and based upon the previous names itself, their symbols were evolved. Okay, so don't get confused because of these different symbols then based upon their name. So these symbols were taken from their previous or older names because they were conventionally accepted. So let us move ahead. So in our upcoming video, we are going to cover certain topics like atomic mass, how atoms survive, what is molecule, what what is an ion, how to write chemical formulae, what is molecular mass, what is molar mass, and what is mole. So these topics we are going to cover in our upcoming videos. Till then, please do subscribe, like, share, and comment this video. And thank you for your participation. Stay safe, stay home. Thank you.